Right, so we're going to talk about the probability of independent and dependent events. So independent events are when we find the probability of each event occurring. The events do not affect each other. So it might be said with replacement. So you'll find the event of one and then the other, and then you multiply them. Probability of event 1 times the probability of event 2. Whereas dependent events, they influence the probability of other events. So that would be commonly said without replacement. So what that means is you find the event of the first thing. So you find the probability of event 1, and then you still multiply it by the probability of event 2. However, if it's like a jar of marbles, say we have 10 marbles, and my first event, let's say I want to just all of them are blue, right? So I take a blue marble out, 10 blue marbles. And when I find the probability, I'll pick out 2 blue. So what that means is that the probability of my first event happening is 10 out of 10, right? But if I'm taking a blue marble out of those 10 and I'm not putting it back into the bag, that means now I only have 9 occurring, 9 marbles in there, and 9 of them are blue. So you subtract. With event 2, you subtract event 1. If that kind of makes sense. And we'll talk about that. So for these first couple things, you're going to want to start by figuring out, is it independent or is it dependent? Okay, so read that problem for me real quick. All right, so we roll a regular 6-sided dice. What's the probability of a row of 2 and a 5? Well, first we have to figure out, again, are they independent or dependent? Does my first roll affect my second roll? Hopefully you're thinking no, so it's independent. Independent. My first roll does not affect my second. Right? So I could roll a 2 both times, but whatever, it doesn't change based off of my first roll. Okay? So what's the probability of rolling a 2 on a 6-sided dice? Remember, a 6-sided dice has a side that's a 1, a 2, a 3, 4, 5, and a 6. So my probability of rolling a 2 is a 1 out of 6. What's the probability of rolling a 5? A 1 out of 6. So now we're going to multiply these two probabilities together. The probability of the first event and the probability of the second event. And we're going to multiply those. So remember, you could type that into your calculator, or remember with fractions, we multiply straight across. 1 times 1 is 1. 6 times 6 is 36. And then here's the big thing. We need to simplify if you can. All right. So I want you can't simplify that, so it stays that way. I want you to read number 2 and do step 1. Figure out if it's independent or dependent, and if you can, and explain if you can. All right, so hopefully you paused and read that. Here's the big thing. A marble is selected and not returned. That's the kicker there, not returned. Okay, the not returned part. So that means it's dependent. Because we are taking a marble out of the bag and not putting it back. Okay, so let's find the probability of each event. So there are 2 red marbles. So there's 2 red marbles and 4 blue marbles. And we want to find the probability of 2 red marbles. So how many marbles are there in total? 1, 2, 3, 4, 5, 6. There's 6 marbles, right? And I'm taking a red marble out. So that's 2/6, or really 1/3, right? So now I'm taking a red marble out. So now I only have 1 red marble and 4 blue marbles left because I'm taking it out and not putting it back. So how many marbles do I have now? I only have 5 marbles, and 1 of them is red, right? Because the other marble is out of the bag, right? If this is, oh gosh, that's way too big. If this was my bag, this was my bag. I have 1 that I already took out. Okay, so now I'm going to multiply those probabilities. 1/3 times 1. And again, we want to simplify. So if you didn't simplify up here, you'll have to simplify at the end. But it's 1 times 1 is 1, 3 times 5 is 15. So it's 1/15. All right, so let's keep on going. So we've a couple of problems to do together. Find the probability. So first we want to figure out, is it independent or dependent? Roll a dice. What's probability we'll roll a 3 and then a 6? Well, that's independent. They don't affect each other. Probability we'll roll 3 is 1/6. Probability I'll roll 6 is 1/6. Multiply those. So figure out what 1/6 times 1/6 is in your calculator. Hopefully you get 1/36. Next one, re-roll a number cube and flip a coin. Do those affect each other? Does what I roll on the dice affect the coin? Hopefully you're saying no. So it's independent again. So it's probability given even number. So an even number, 2, 4, 6, that's 3 out of 6 for an even number. And land on tails. Well, a coin is heads or tails, so that's 1/2. So I know that 3/6 can really be simplified to 1/2. Right? So I want to do 1/2 times 1/2. So what is 1/2 times 1/2? Hopefully you got 1/4. If you did 3/6 times 1/2, you would have had to simplify because you would have gotten 3/12. Okay. So a drawer contains 6 red socks, 4 white socks, and 8 black socks. What's the probability you grab a white sock and put it back and then grab a red sock? So you're in your drawer, ruffling through your sock drawer. You grab a white sock out. You're like, nah, I'm going to put that back and grab a red sock. So is the total number of socks changing from each time I reach in? No, right? Because I'm putting it back. So this is independent still. So how many socks are there altogether? There's 6 red, 4 white, and 8 black. So that's 18 total. So what's the probability I'll grab a white sock? Well, there's 4 out of 18. And then a red sock. A red sock is 6 out of 18. So let's simplify these probabilities first. 4 18ths can be simplified to 2 9ths. 6 18ths simplifies to 1/3. Okay, so let's multiply those. 2 times 1 is 2. 9 times 3 is 27. So you should get 2 27s as your answer. All right. Let's do number 5. So same premise with probability. 6 red socks, 4 white, 8 black. What's the probability I choose a black sock? Don't put it back and grab a white sock, right? So I'm grabbing, now they're no longer together. Think about it as reaching a sock drawer. You're just trying to pull out 2 of them and you want 1 black, 1 white. And when I take out the black one, I don't put it back in because that's what I'm putting on my foot, right? So these are dependent then. They're dependent. So the probability I'll choose a black sock is 8 out of 18. I'm going to simplify that fraction first. So 8 out of 18, both can be divided by 2, which will be 4 9s. Okay. And then we don't return it. We grab a white sock. So since I took out a black sock, it's going to be out of 17 now. Because I took out a black sock and didn't put it back. And then but I'm grabbing a white sock. So there's still 4 white socks in there. So now we're doing 4 9ths times 4 17ths. And we're going to multiply those together. So figure out what 4 9ths times 4 17ths is. All right, so I got 16 over 153, and that's as simplified as it can get, I'm pretty sure. All right, we're going to do one more together. And then I'm going to have you do number 7 on your own. So there are 4 blue marbles and 2 red marbles. A marble is selected and not returned. What's the probability 2 red marbles will be doing? Okay, so this is dependent, right? So we have, for the first time, 2 red, right? So the first one is 6. So out of 6 marbles, we have 2 red, or we have 1/3. The second time, we only have 5 marbles left in there. And because I already took out a red one, only one of them is red now. So what's 1/3 times 1/5? You should get 1/15. Okay, so I want you to do number 7. So a marble is selected without looking and replaced in the bag. So these are all independent. So think about how many total marbles there are, by the probability of black, multiply it by the probability of yellow. And that's what you're doing for those 4. Okay, so try that on your own. We'll go over that together next time we see each other.